Hello everyone. Today we will start to answer some questions about limit of reading, level of accuracy, absolute error of a measurement. So we have a measurement. We want to precise. We want to search for the limit of reading, level of accuracy, and absolute error of this measurement. So what we mean by the limit of reading and the greatest possible error. Okay, so we have here error. So how to find the limit of reading? We will read the remark on the right. The limit of reading of a given measurement, if not indicated, okay, so it is not specified, is the last significant figure. Okay, so we will have an example. For each of the following measurement, find the smallest unit of measurement. So the smallest unit of measurement can be known as the limit of reading. So we can define the limit of reading by the smallest unit of measurement of 18 centimeter, for example. So for us, 18 centimeter, okay? We have the first significant, the second significant figure, okay? So the second significant figure is the last one here, okay? So this digit is the unit digits. So the limit of reading is 1 centimeter, okay? So it is very correspond to the digit where is located the last significant figure, okay? So the limit of reading here for the example 18 centimeter is 1 centimeter, okay? So it is 1 centimeter defined by the smallest unit of measurement, okay? So very good. What we mean by the greatest possible error? The greatest possible error equal to the limit of reading that we have, or we can say it multiplied by 1/2, or we can say it differently, the greatest possible error equal to the half of the limit of reading. Okay, so we can move to solve, okay, to evaluate some the limit of reading and the greatest possible error for some different examples. For example, for the 2.4, like we say here, 2.4. First, the limit of reading is not indicated, so we should search it by ourselves. So we search for the last significant figure. So the first one, the second one, which is the last one. So 4 here. So for us, it is equivalent to 0.1, to the first decimal place, which is equivalent to 0.1 kilogram. So the limit of reading is 0.1 kilogram, okay? The greatest possible error, it is equal to the half of this value. So 0.1 by 1/2 equal to 0.05 kilogram. Very sorry, I have an error here, okay? So kilogram, okay? So good. For example, 12.6, which is here, okay? So the first figure, significant, second, third one, which is the last one. So 6 is located in the first decimal place. So we can say here that the limit of reading is equal to 0.1 second. 0.1 second, and the error, the greatest error, possible error, it is equal to the half of this value. Okay, so the half of this value equal to 0.05 second. Okay, so we can move to the 14 minute. 14 minute we have in the exercise 4HD 14 minute. 14 minute, we have here a whole number, integer number without a decimal point. So 14, the last significant figure we can count from left to right. So 4 is located in the unit digit. So the limit of reading is 1 minute. 1 minute, and the error, possible error, greatest possible error, the half of 0.5 minutes. Okay, 8.1 liter, 8.1 liter. So the last significant figure counting from left to right is 1, which is located in the first decimal point. So the limit of reading it is equal to 0.1 liter. So the half of this value equal to the greatest error, possible error, which is equal to 0.05 liter, and etc. Okay, very simple. So first we explain the limit of reading and the greatest possible error. So how these vocab are related to the limits of accuracy. And so the limit of accuracy, we can calculate it using the measurement, the original measurement that we have, and we can add the greatest possible error or subtract it. Okay, so if we have, for example, 16 seconds, so the last significant figure is 6, which is located in the unit digit. So 1 second is our limit of reading, and the greatest error, possible error, it is the half of this value. So 0.5 second is our greatest value. So for us, the limit of accuracy, it is equal to the measurement, which is equal to 16 plus minus, so plus minus 0.5, the error. So we obtain 16 minus 0.5, it is equal to 15.5, and 16 plus 0.5, it is equal to 16.5. In this step, when we obtain the limits of accuracy, we obtain the lower limit, lower 15.5, and the upper limits. Okay, using the lower limit and the upper limits, so we can obtain the range where the true measurement below are included. Okay, the range that equal to the range, because we have here greater or equal and smaller strictly than of lower and upper limits respectively. Okay, so you can find also on the right second example, or the part C of this exercise. Okay, so first we search for the last significant figure, which is located in the second decimal place. So for us, 0.01 is the limit of reading. So the half is equal to 0.005 meter. Okay, so we obtain the limits of accuracy, the lower the upper limit, by subtracting and by adding the error 0.005. So we obtain as range 0.375 and 9.385. Okay, we can complete the following for a measurement also in the same way. So very easy to see the details of these exercises. So don't hesitate to ask some questions to or to clarify any idea. The exercise 4 is similar to the exercises previously done. In the example 3, we can see in the given that they specified the limit of reading. How? The mass of car was given as 2,300 kilogram to the nearest 100 kilogram. So this the, this this expression to the nearest 100 kilogram, we can say that they specified, they indicated the limit of reading. So how to find the limit of reading? Using the nearest 100 kilogram. For us, in this given, they specified, okay, they specified and indicated the limit of reading by 100 kilogram. So based on this limit of reading, we can find the greatest possible error. So it is the half of 150 kilogram, okay, and we can add subtract to obtain the lower limit of accuracy and the upper limit of accuracy, adding, subtracting, and adding respectively. So we subtract 50 from the original measurement, which is equal to 2,300 minus 50, we obtain 225 to 2,250 kilogram, and the upper limit equal to the original limit plus the error equal to this one. Okay, the range, we can use the lower and the upper limits of accuracy to obtain the range. Okay, greater or equal from the lower and smaller strictly from the bigger or the greater limits, upper limits. Okay, so very easy to use and to solve the next exercise, which is the exercise 5. In the example 4, we need to find our two so in the example 4, we will use the correct correction to a number of significant figures, some significant figures. Okay, so he gives that he say that if 17 meter of rope is to be cut into 3 equal pieces. Okay, so 17 meter we divided by 3. Calculate the length of each piece correct to one significant figure. So first we divide 17 by 3, we obtain 5.666666 meter. We are using the meter as unit here. Correct it to one significant figure. One significant figure, we count the significant figure from left to right, so 5 to the unit 5. So 5, we compare the digit on the right, the number on the right, so 6 is bigger than 5, so we can add 1 to 5, we obtain 6, and we replace all the digits on the right by 0, we obtain 6, 0, 0, 0, so 6 meter. Okay, 6 meter, which unit of length would be appropriate to achieve each of the levels of accuracy? So in this level of accuracy, we have 6. The last significant figure is on, it's located on the unit, and we have meter as unit measurement unit. So the meter is very appropriate here. Okay, using the correction to three significant figure. So 1, 2, and the 3, we are here. We are in the second decimal place. Okay, so we compare which is our 6 on the right, so it's bigger than 5. So we can add 1 to the second decimal place. We obtain 5.67 only. Okay, so which unit of length would be appropriate? We want to search for the unit of length, appropriate unit of length to achieve this level of accuracy. So the last significant figure is here, like we see here. Okay, so this is the one. For us, the unit is correspond to the unit measurement that we have. Okay, on the right, we can say that we have decimeter, centimeter. Okay, so for us, the last significant figure, okay, it corresponds to the centimeter. So the centimeter is the appropriate unit of length. As we see here, the base unit is meter, and on the right we have decimeter, centimeter, millimeter, and on the left we have decameter, hectometer, and kilometer. Okay, so in the third part, the correction of the length to fourth significant figure, we obtain this one. The appropriate unit of length correspond to the unit of length of the last significant figure. So we have the base unit is meter, so we count decimeter, centimeter, and millimeter. So millimeter is the appropriate unit of length, okay, etc. So we can also solve the exercise 6 and 7 easily, because it's based on the same idea of the example 4. Okay, so in the example 5, we should know that more the number or the measurement contains significant figures, more the number is accurate. So if we have a number with a greater or bigger, a bigger number, so bigger numbers, so we mean by that more accuracy. Okay, so like here we have two numbers, 8.76, 8.760 kilogram. Okay, we have the same weight unit here. So, but we have here 3 significant figure, on the second we have 4 significant figure. So for us, the accuracy is more achieved by the second measurement. Okay, and so on. You can easily solve the exercise 9, which is adopting the same remark that we explained before, and you can take all the remaining exercises as homework. Thank you for listening. I'm waiting for any of your questions, and bye-bye.